Hello everyone, welcome to Untuition. In today's video, we are going to learn about concentric spherical metal shell configuration. So in this video, we will try to understand what will be charges on each surface of spherical conductors if we put few charge on the spherical conductors, and also what will be the potentials of each spherical conductors due to those charge distribution. So let's start with a metal shell of radius A, and let's put some plus q charge over that sphere. And as soon as I put that charge on that sphere, as you can see from the property of conductor, this plus q charge will be uniformly distributed over the outer surface of the conductor. And now if we bring some bigger metal conductor concentric to that previous one, say its radius is b, then what will be the charge distribution on each surface of the bigger conductor? Now you can see that for this bigger conductor there is a charge plus capital Q inside it. So from the property of conductor itself, can I say that on the inner surface of that bigger conductor there will be an induced negative charge? So minus Q charge will be induced uniformly on the inner surface of the bigger shell. Now to make it neutral, again remember the property of conductor that as soon as minus Q charge is induced on the inner surface, there will be a plus Q charge that will be induced on the outer surface of the conductor. So plus capital Q charge will be uniformly distributed on the outer surface of the bigger conductor. Now suppose we have to find the potential of the inner conductor and the outer conductor also. So let's start with the potential of the inner conductor. I can take any point on the inner conductor and I can find the potential of that point, and I can say that potential of the smaller sphere is the potential at any point on it. So let us assume this point P, and we are interested to find the potential of this point P, which is at the surface of that smaller sphere. So there are different charge distributions, and we are going to apply the superposition principle to find the potential at this point P. So let's start first with the plus capital Q charge spread over the smaller sphere. And we know that any point on the surface of this metal sphere, the potential is simply kq divided by the radius of that sphere, which is A in this case. So the potential at point P due to this charge distribution is simply kq by A. Now forget about this smaller sphere and let us talk about the negative charge that was induced on the inner surface of the bigger sphere. And due to this negatively induced charge, I can consider this to be a uniformly charged spherical shell, and inside this point, because P point is now inside point of this shell, and any point inside that shell, the potential, if you remember, that it's simply kq divided by the radius of that shell. And here also the radius is b, so the potential at point P due to this negatively induced charge is minus kq by b. Now forget about that negative charge also, and now consider the outer charge that is on the outer surface of the bigger sphere. And due to this plus capital Q on the outer surface of the bigger sphere, the potential at any point inside it is simply kq divided by radius of it. So potential at point P due to this plus capital Q charge induced on the outer surface of the bigger sphere is simply plus kq divided by B. So now if I add all these potentials, I can find the potential at point P due to all the charge distributions, and this potential is simply kq divided by A. You can see that this potential is not only the potential at point P, but that is also the potential of the smaller sphere. Here in this end result, we can observe a very important thing, that the total potential is only due to plus capital Q charge that was put initially on the inner shell. The potential due to all the other charges are cancelling each other. It is very obvious, because if you can see that the minus Q charge that was induced in the inner surface of the outer shell and plus Q charge that was induced on the outer surface of the outer shell, both are at the same distance b from the center of the smaller sphere. So we can neglect the potential due to these induced charges at this point P. And we can use this concept everywhere, but the condition is that the thickness of the shell should be very small. Now what will happen if I also put some plus a small q charge on the outer surface of the bigger conductor? As soon as I put that plus small q charge, this small q charge will also be spread uniformly on the outer surface of the bigger conductor. It will not induce any charge inside it, because whatever goes outside the conductor, that has no effect inside it. We have already studied that this effect is also known as shielding effect, if you remember. So now we have to find the potential of this point P, or the potential of the smaller conductor due to all the charge distributions. And again, if we are trying to find it by superposition principle, we can say that due to all the other charges, the potential at point P is the same except for that plus small q charge that is now added on the outer surface of the bigger conductor. So let us only find the potential at point P due to this plus a small q charge. And as we can see that this is also a uniformly charged spherical shell, and at any point inside that spherical shell, the potential due to its charge is simply kq divided by the radius. So here I will say it is plus k small q divided by the radius of the shell, which is v. So now the total potential at this point P, or the potential of the smaller sphere, is now kq by a plus k small q divided by b. So that is the potential of the smaller conductor. Just similarly, in this end result also, you should see that the total potential is only due to the charges that were put externally to the system. The charges that were induced will create zero effect at potential of any point. Now similarly, if I have to find what is the potential of the bigger sphere now, and we have taken a point P which is on the surface of the bigger sphere, and we will find the potential at point P due to all the charge configurations by simply applying the superposition principle that we have just applied earlier. You can pause this video now and try it by your own. After that, you should match whether your answer is correct or wrong. I hope that you can do it. So let's start the potential at point P due to that plus capital Q that was put on the surface of the smaller sphere. And I can say that this point P is outside point of that sphere. And at any point outside on a metal sphere, the potential is simply kq divided by the distance between the center of the sphere and the point P. Here this point P is on the surface of the bigger conductor. So the distance between the center of the smaller sphere and this point P should be the radius of the bigger conductor, which is B. As those spheres are concentric, so the potential at point P due to this plus capital Q charge is simply plus capital Q K divided by B. Now forget about this sphere and let us talk about the negative charges that were induced on the inner surface of the bigger conductor. And due to this negatively charged uniformly shell, I can say that P point is on its surface. So potential at any point on its surface is simply kq divided by radius of that sphere. So it will be minus kq by B. And let us talk about the final charge that are induced and put on the surface of the bigger sphere. On the outer surface of the bigger sphere, there are total capital Q plus small q charge uniformly spread over the surface. So at any point P on the surface of that sphere, the potential will be simply K small q plus capital Q divided by its radius, which is B. So the total potential at point P due to all the charges, if I add those, will be K small q plus capital Q divided by B. And this is not only the potential at point P, but it is also the potential of the outer shell. As I have already discussed the earlier cases, here also you can see that the potential at this point P is only due to the charges that we have put from external sources. The charges that were induced will produce zero potential at this point P because the thickness of the shells are negligible. We can always use that. If the thicknesses are negligible, we can find the potential only due to the charges that are put externally. The induced charges will create no potential. We can neglect those. So in this way, we can find the charge distribution at all the surfaces of concentric shells, and also we can find the potential of all the shells individually. So let us try a question, and we'll try to apply all these concepts that we have just studied. So for example, I have taken concentric spherical shells, and there are three concentric spherical shells A, B, C of radius small a, small b, small c respectively. From externally, I have put capital Q, minus 2Q and plus 3Q charge on the surfaces of those spherical shells. Now I have to find the potential of each shell as well as the charge distribution on each surface of the shells. So to find the potential, we will only consider the external charges if the shell has negligible thickness. Why? For example, let us assume that this plus q charge will induce minus q and plus q charge to the inner and outer surface of the middle shell. So the potential at this point due to this minus q charge is minus kq by b, as well as the potential due to this plus q charge on the outer surface is also plus kq by b. So they will cancel each other. So remember that if the spherical shell has negligible thickness, in order to find potential, do not consider the induced charges, only consider the externally put charge on those spheres. So if I have to find potential at any point on the surface of this smallest sphere, then I have to first find potential. So let us write potential at A. So that is, first I have to take the potential at A due to this blue charge, which is K capital Q divided by small a. Then I have to find potential at this point due to this red charge, which is K into minus 2Q divided by B, and then I have to find the potential at this point due to this green charge, that is K into 3Q divided by C. That will be the potential at point A, right? So very simple. In the similar way, I can find potential of the shell B. So what is potential at any point on the surface of the shell B? So let us first consider the blue charge. So due to this blue charge, the potential at any point externally, which is K Q divided by the distance between the center to that point, and it is on the surface of the middle sphere, so it is K into minus 2Q divided by B, and this point is inside point to the outer sphere, so it is simply K3Q divided by its radius C. So that is the potential of this point B, as well as the potential we can find of the outer shell. So if I take the any point on the surface of this outer shell, due to this blue charge, this potential will be kq by c, because that will be at a distance c from its center. This red charge, it will be k into minus 2q divided by c, because also from its center that point is at a distance c. And for this green charge, that is k into 3q divided by c. So that is the potential of this shell C. Now let us come to the charges. So as I have kept this q charge here, so this plus q charge will induce a minus q charge on this surface, and plus q charge on this surface. Again minus q charge will be induced on this surface, and plus q charge will be induced on the outer surface of the bigger sphere. So now let us consider this minus 2q charge. It will induce plus 2q charge on the inner surface of the bigger sphere, and minus 2q charge on the outer surface of the bigger sphere. So that is the charge configuration. You can see that on the inner surface of this smallest sphere there is no charge. Outer surface of it there is plus q charge. On the inner surface of the shell B has minus q charge, and outer surface of the shell C has minus 2q plus q, that is equal to minus q charge. And similarly on the inner surface of shell C has plus 2q minus q, that is equal to plus q charge, and on the outer surface of the shell C has total charge 3q plus q 4q minus 2q, which is 2q charge. So that will be the charge distribution on each surface of the shells.